Okay, good afternoon, everyone, and thank you for being here for the two last sessions of the day this afternoon. As you can see, for this session, we will need to have installed Crossmark and MetaMask. I think this morning you already used MetaMask or any EVM wallet. But for this session, Crossmark is required. It's a VM wallet that supports the testnet for the demo that we are going to do. Okay, so let's start. I'm Mathis. I'm really happy to make this presentation this afternoon because I'm going to talk about the topic I'm working on at XRPL Commons, which is interoperability between blockchains. In this presentation, we will get an overview of interoperability and a small focus on the XRP Ledger. Imagine a world where when you want to send a text message to someone, a friend who has another smartphone brand, you must use an external tool to translate or to convert the message to be received on the other smartphone. Or let's take another example, a more sunny example. You are on holidays, and every time that you want to make a payment, you must convert the currencies, but also to have a local bank to accept the payment locally. It's crazy, and blockchains were supposed to fix that. Decentralized finance aims to bring a global, worldwide exchange that is available at any time in a decentralized way. But the solutions that are provided today are very blockchain specific. They provide very specific routes, very specific direction, which make the user experience terrible. And blockchain, so what I suggest first is that we start from the very beginning. What is interoperability? Interoperability has been defined in 1996 by a well-known professor called Peter Wegner as the ability of two or more software components to cooperate despite the differences in languages, interfaces, and execution platform. As you can see, this definition is very general. It's applied to computer science, but also in data and communication in general. One of the use cases that I really like is aircraft. Not only you have to interoperate the data between the different companies, different manufacturers, but also in the conception of the aircraft itself, they have to make sure that the way they build the tools or the components are correctly handled, correctly interpreted, and the data also between different aircraft. And if we try to specialize a little bit this definition for the blockchain, we can have ability to share and access information across different blockchain networks without trust entities, ensuring consistency and reliability. In fact, blockchain came with a very strong commitment in terms of decentralization, in terms of the mobility of the data, but also the ownership of the value with cryptography. And when we want to bridge, we want to make sure that we still preserve these properties. When we want to start building tools for interoperability, we ask us three main questions. First, at which level of interoperability do we want to operate? The first one is semantically, so it's just about how do you communicate the data. It can be also at the application level. You are building a smart contract and you want to make the smart contract in different blockchain, between different blockchain, communicate between them. And it can be also at the protocol level, when you want, for example, to share value in the protocol itself. The second question that we ask is, what is the object of interoperability? Often it's assets or generic messages. And finally, the last question is, what is expected? Because when you transfer these assets, often there is a logic behind, something happen. The first use case is just asset migration. You are on one chain, you just want to bring the value to this other chain. The second use case is asset swap. So instead of bringing the representation of a value to another chain, let's imagine that you have XRP on the XRP Ledger and I have BTC on Bitcoin, the chain. I will send my BTC to your address on Bitcoin and you will send your XRP to my address on the XRP Ledger. And finally, it can be just synchronization or coordination of different action between smart contracts in term of logic in general. Once we have started to create this architecture, we face different challenges. The one that we heard the most about is atomicity, to make sure that the value that have been bridged stay the same. We don't duplicate the value that can lead to a loss of the value of the asset. And the second one is security, because we have a lot of hacks in blockchain that concern bridges and interoperability in general. But we have many more things to consider. Integrity, if you bridge data or bridge asset, you want to make sure that it's the exact amount that you requested. Privacy and traceability, it's one of the core properties of the blockchain, and you don't want also at the same time that people use your bridge as a way to hide where the funds come from. And finally, scalability, because many proposals have been made, but it's often very heavy, computation heavy or costly. So we have to make sure that the tools are being possibly used by a lot of people at the same time. So let's go back to our blockchains. Now we have a lot of different architecture that are available. The first one, the most used one today, is notary chain, which is basically trusting someone or a committee of people to observe what happened on one chain and perform the action on the other chain. Hash-time lock contracts, wrapped assets, but the most promising one, I think, is light clients and zero knowledge proofs. So where are we today? The first problem that the industry started to resolve was about assets, being able to use assets between different blockchains. So today we have a lot of solutions, even if it's about a minute, it's not instant. Still we have Wormhole, we have Layer 0, we have a Cross or Squid Router. These solutions are mostly based on top of a protocol. Squid Router that we are using is based on Axelar, Stargate is based on Layer 0. Then the industry and researchers started to work on, when the programmability came, they started to think about how can we just send generic messages between blockchains. So we have, again, Layer 0, Axelar, or chaining that perform this type of transaction. And today, different application, main application in the ecosystem try to have the most abstracted to reach as many users as possible. And we can see these 4 main projects in the ecosystem. Safe, which is a multi-sig project, account abstraction, the biggest project on account abstraction on EVM, that is working. They are working on the network so that they can fully abstract for the user the use of their account abstraction, but still this network will be then able to communicate with these different blockchains. Another example is Chainlink. It's a team, they were initially focused on oracles, and they are using their different entities to verify the states, perform actions on chain, and their protocol is called CCIP. One-inch, they are specialized in swap, initially mostly for the EVM ecosystem, and now they are trying to extend their swap to non-EVM blockchains. And finally, AAV, they mentioned on their roadmap. Right now, they are already using many interoperability applications to bridge liquidity. AV is a lending borrowing protocol. They are bridging liquidity when when there is a lack of liquidity on one chain. They use layer 0 and CCIP. But on the roadmap, they mentioned that they want also to launch their blockchain, to have their protocol as the core at the protocol level, the lending borrowing app. And then this blockchain will be able to communicate to bridge liquidity between different blockchains. Okay, we talked enough about different actors in the ecosystem. What about the XRP Ledger? The XRP Ledger was one of the first blockchain to face this problem because they were for a certain amount of time alone with BTC. So a team from Ripple started to work on a project. They called it Interledger. Today it's a foundation, it's a non-profit. And they started in 2015. They wanted to create a project that support not only cryptocurrencies, but different types of value in general. They could support banks, mobile app. And to design this protocol, they use what we already know with the World Wide Web protocols. They use packets and connectors. Connectors will verify first, and relay these packets across the network. And with the launch of the XRPL EVM, the ecosystem, the XRP Ledger ecosystem had to find a solution that allowed the bridge of value between different blockchains specifically. And to do so, they use Axelar that we mentioned earlier. Axelar is a notary-based bridge. As I said, it's basically to trust a committee of 32 independent verifiers. They verified the state, the transaction, if the transaction have been correctly made on one chain, and they execute the transaction on the other chain when enough validator approved this bridge. On the XRP Ledger, it's represented as a multi-sig account of 32 validators. They have their own keys, and they can approve the transactions. Okay, let's bridge. So, as I said yesterday, you used Crossmark, Xaman, but unfortunately Xaman Squid Router don't support Xaman on the testnet, which is very specific anyways, and I mentioned MetaMask, but you can use any EVM wallet. You just need an address to perform the bridge. So Crossmark is a browser wallet, not a mobile app. And the first, feel free to do as you want. I think yesterday you generated address with the code. I think the most simple way is just to go to XRP Faucet to create an address and copy paste the secret. Okay, did you manage to install Crossmark, create your wallet, import it on Crossmark? Do you face any problem? Yes? So when you import when you want to import your secrets, you have to select seed in Crossmark. Then you can go back to the main screen, the home screen, and select testnet. And now we can go to Squid Router. It's testnet.xrpl.squidrouter.com. So if you are already at this step, you can, I think, easily go further, but I will go back from the very beginning. We have to use Crossmark as the XRPL wallet, and any EVM compatible wallet, such as MetaMask, that you used this morning. Once you have installed both, we need to configure them. The first, feel free to choose the way you generate a wallet. The easiest way is to go to the website XRP Faucet, which will generate for you a testnet wallet, a founded address, and you can copy paste the secret. Then you can open your wallet, your Crossmark wallet, and you can select import existing wallet. They will probably ask you to configure a password or a PIN or something to secure the access to the wallet. You proceed with import and you select seed to import your secret. Still on Crossmark, you go back to the home screen and you select the testnet network. Then you will have your XRPs that will be displayed on the main screen. You will have 9 XRPs and 1 for the reserve. And on the other side, you can, if it has not been done this morning, you have to configure your EVM wallet, such as MetaMask. It's the same process, but it will generate an EVM compatible wallet. Okay, and now you can go to the website testnet.xrpl.squidrouter.com, which is the testnet version of SquidRouter. They build it only for the XRPL. So the website is a bit hidden. I don't think that you can find it just by clicking on Google. So testnet.xrpl.squidrouter.com. We have our Crossmark wallet ready. MetaMask is ready too, and we are on the SquidRouter website, testnet.xrpl.squidrouter.com. And we can connect both wallets. The first one, if you have selected XRP from the XRP Ledger first, and XRP on the XRPL EVM as a destination, you can click on Connect, and it will open a pop-up where you can select Crossmark. It will open a pop-up on your Crossmark wallet, asking if you allow this connection. You can select your wallet and connect. So, as I said, for this step, you just have to select Crossmark, and then to select on another screen to select the EVM, but don't click on XRPL MetaMask Snap, it's something different. So the next step is for the EVM wallet. So when you have connected your Crossmark wallet, you can connect again your second wallet, and then this pop-up will be displayed, and you can select any EVM wallet. It will detect MetaMask, so you can click on MetaMask, connect your account. Okay. So if you have connected your Crossmark wallet, then your EVM wallet, you can bridge. So what is happening on this screen? The very first line, you have your XRP Ledger address. Then you have selected both the network, the source network, and the token that you want to send. The source network that we've selected or have been by default selected when you arrived on the page is the XRP Ledger. And the token is the XRP, which is the native asset. You can enter the amount that you want to send. Then it will display for you the average time of the transaction, average fees, estimated fees. And on the second part, you have receive. Second part is the destination data information. You have received, then the EVM address that will receive the funds. Again, you have both the network and the token. You have the XRPL EVM, which is the new blockchain in the ecosystem, and the XRP token. And then finally, you have the estimated amount. As you can see, it's way lower than the amount you selected, you entered from the source chain. And this screen is specific to the testnet network. Axelar, which is the protocol behind, will take an amount, in our case 3 XRP, which is a lot, but they want to make sure that they could have enough fees to perform the transaction. In fact, most of the time, a transaction will cost about 0.2 or 0.5 XRPs. So they will still take 4 XRPs. You will receive, probably if the transaction happened well, 1 XRP. And the difference between the fees and the amount, the approval that you gave, will be returned on the source chain. So you send an amount for the transaction fees, they use just what they need, and then they return it on the source chain. So probably that on the main net, you will have 4 XRPs, and you will receive about 5 XRPs, sometimes more, sometimes less. And the average time of this transaction is about 2 minutes. And yes, that's it. Bridges, in general, this is a question that I thought to write on the quiz. Bridges in general take about 1% fees of the transaction. So Axelar costs more, and that's one of the challenges when you are using notary-based bridge. When you trust someone, and you proceed transaction between different types of blockchains, such as the XRP Ledger, Bitcoin, it often costs more than something that we call homogeneous blockchains, such as the EVM ecosystem, because you have a lot of parameters to consider, sometimes more slippage. Anyways, so you can swap, and then you will have a pop-up. And this pop-up is very interesting. This pop-up will appear on Crossmark because it's on the XRP Ledger that we perform the transaction. Axelar will verify this transaction. The 32 verifiers will look at your transaction. They will all approve or not. And then send the information to the contract on the EVM blockchain to send the funds. And what is very interesting with this payment transaction is that we are using memos that you saw on the first day, and this time it's essential. It's to perform the bridge because we are sending the data to perform it. The first parameter will be, I don't remember the order, but the first parameter, if I remember well, is the address of the contract, destination address on the EVM chain. It's something that we called a gateway. Okay, sorry, I'm wrong on so the destination address will be simply your address on the EVM. First parameter, destination address, your address on the EVM. The second parameter will be the fees. So you process the fees. It's like the maximum amount that you accept to be taken as fees, else the transaction will be reversed. The third parameter is the destination network. You have to precise to Axelar which network you are targeting. And that's it. So this type of yes. Theoretically, it's supposed to be reversed. So they will take the fees and send you back all the funds. So if the verifiers don't reach consensus, so some verifiers say no, or if the transaction fail on the EVM chain, it will send. The flow is we verify till the very end that the entire flow have been proceed, else we return found. In fact, I think that the this flow of returning found is not fully functional. Maybe I'm wrong, but I've performed many swaps and it seems like it's not fully implemented. But yes, this is one of the challenges. You have to consider in interoperability in bridges in general, what happens if it fails. And the process for notary-based bridge is that we look at the transaction till the very end, and if it is not happening, sometimes you have even a time to perform it, and if the time has been reached, the funds are returned. Yep. So theoretically, Axelar support the return amount. Practically, I've lost, I think, 2 transactions where it just have not been performed because it wasn't fully implemented. So with this first screen, you can notice that we have these 2 networks and the XRPs, but XRP is also, there are representations of XRP on Base, on BNB chain, Binance Smart Chain, and many other blockchains. So typically Axelar could allow us to perform bridge from the XRP Ledger to Base with the token XRP and the representation of XRP that they've built on their own chain. So Axelar allow transactions bridge between different types, different architecture of blockchains. Okay. So did you manage to perform the bridge? So I think you can see it on this screen, this first screen. You have a balance on top, bottom right. Else, you have to import the token because it's on the testnet. So you have both to import the network and the token on MetaMask. You can use chain list, and you have you just type XRPL EVM, and there is a button add to MetaMask. Okay, so thank you everyone. I hope that you enjoyed the session and you managed to perform the bridge. The next session will be Thomas, and you will perform, you will create cross-chain apps. He will talk about cross-chain applications, and he will perform through the code the same cross-chain transaction that we've done with these interfaces from Scributor.